Hello coders, welcome to my video. In this video, we'll see how to extend the dynamic memory. For example, if we have a memory that is already been allocated using malloc or calloc, and at certain point in program execution, we want to extend or shrink the memory depending on our requirement for optimizing the memory footprint of our program. So how can we do that? So let's take an example. If I have in memory, for example, int star of array, and here I have a malloc, and I am using size of int. Yeah. So five integers I'm allocating right now. Okay. So this I'm checking as it should not return null. If it return null, it should exit from here. Okay. So I need to extend this memory of five integers to 20 integers. So we can use an API named realloc to extend this memory. So what is the syntax of this realloc? We have realloc. So we have two arguments. First, we will give the address of the memory that we want to extend. So it should be array. Then we should give the memory that we need. For example, I need 20 ints here. Okay. And it will return you the address of the new memory. So like this. So what I will do, I'll put some values in this array. So for example, int I is equal to 0 to I less than 20 if I say, and then I have I plus plus, and array I is equal to I plus 1. Okay, and here I can print the array. Printf, then I have percentage d comma, okay, and do like this, and here I have array, then I have I here, and I'm printing this array. Okay, so let's see. Okay, so detected the memory leak. So it's showing me because I have not freed the memory. So what I will do here, I will free the array here. So again, if I compile it, oh, I think here I don't have to do this. So I'll get this value from 1 to 20. Okay. So let's analyze this a little more. So we already have a pointer array and it is pointing to this array of five integers. So, what is this memory? Is it different or it's the same memory? So, we are extending from the same place. I am reusing this pointer. So, this pointer is already have the allocated memory of five integers, and we are passing it and we are extending this memory to 20 integers. So, are we extending from the same place or we are extending from a different, we're taking a different block of memory in the heap? So for that, what I will do, I'll print the address of the pointers over here. So what I will do, I will do printf when I have the original pointer is equal to percentage p, and it should be void star, and then we have array here. And what I will do here, I will take the new pointer here. Okay. So I want to check whether these two memory are extending from the same address or it's a different location. So let's compile this and see what will be the output. So if you see here, the original pointer is different from the new pointer. So the memory that is allocated by realloc is a different block of memory starting from this address and extend to 20 bytes. Whether this is the original pointer that contains five integers. So what happens to this memory when we give this pointer to relock? So what relock will do, it will free this memory first, and then it will allocate new memory and give the address of memory to this array again. So first it will remove this memory and then the same pointer it will allocate the new 20 bytes. So how to prove that? So using the same pointer here and here may be dangerous. So if this relock got failed, so this memory will not be freed. So it unnecessary accommodate the memory and we won't utilize it. So better we should use a different pointer in spite of using the same pointer here. So what I will do, I'll take a temp pointer here and int star of temp. So the new pointer should be temp here, and here the same way I can use a temp. Okay, and here while freeing it, I should use a temp. So what if I free the this memory as well? To check whether this array memory is being removed using this realloc or not, I'll free this array memory here. And let's see what will be the output. So if I run it, see I am getting some memory issue. It's showing the double free. So the location of this problem is something at 18 number line. So let's see what is there in 18 line. So it's the same location. So if I remove this, this error will be gone. Okay, so this proves that this memory is already being used or freed by this realloc. Okay, so here we can have a check if it is null, then this relock will fail. Okay, and here what I will do, I will free the array that time. So printf, if I take here and I will say maybe malloc failed, something like that. Okay, and it should return 1. Okay, so if and any condition, if this memory is not been allocated, it will return null by default. And that time we need to free this pointer and we will print the statement and return from here. Okay, so this is the way we will be using the relock for extending the memory or increasing the size of the memory. So what if I need to shrink the memory which I already have? So if I have 20 bytes already and I want to shrink it to 5 integers now. So I will remove this, okay, for now. And so here, if you see, we have the original pointer at this location and the new pointer that is being shrinked is in this location. So what I will do here in order to check whether it's been shrinked or not, I try to access the location greater than this. So I will try to access 7 and I will put a value 24 here. Okay, then when I compile it and run it, see, I get a segmentation fault over here. So this segmentation fault is heap buffer overflow. So we are accessing the pointer at a location that is outside the bound of the heap memory. So that is at the location 18. So if I go back to this location and see, so it's showing this one. So earlier we have 20 integers and now it shrink to 5 integer values. So we can use this 5 integers now, not the 21. A few more points about this relock is the memory that is we are getting from this relock is similar to malloc. It's not been touched, not zeroed like we do in calloc. So whether we are getting this memory from malloc or calloc, ultimately the realloc will give you the memory similar to malloc, that is untouched and non-zeros. They may contain the dummy values or some garbage as well. So we need to do the memset of that memory to make it usable. This is all about realloc. So let's see in the next video. Thanks.